Number 5. It is here. It's in your face. Let's do it. We are going to continue the 1998 AP Calculus AB free response questions, numero 5, number 5. And hey, all right, we get a graphing calculator to use. It's always nice. So, without wasting any more time, like the video, because I know you're going to like it anyways. Follow me so you get notifications for everything else I put up, including question number 6 when that video comes up. And again, that helps me out with my time and energy, and you know, it validates my feelings because you like me. All right, number 5, let's get going. Number 5 reads, the temperature outside a house during a 24-hour period is given by capital F of t equals 80 minus 10 cosine of pi t over 12 from 0 to 24 inclusively for my variable t. All right? F of t is measured in degrees in Fahrenheit, and t is measured in hours. So first of all, shame on you if you can't do part A. Sketch the graph of f on the grid below. You have a graphing calculator. But first, let's actually review some pretty basic things for graphing trigonometry. All right, let's go here. Midline, this is where I start. Okay, in the middle at 80. My midline is going to be at 80. Okay, it's a cosine curve, which means it's going to be a cup, but it's negative. Okay, which means the cup is going to be open downward. All right, in the middle or midline of 80 is right there. All right, my amplitude is 10, which means if 80 is the midline, it's going to go up 10 to 90, the high point, down 10 to 70, the low point. All right, and how long is this? What is the period? Well, I take whatever I'm multiplying my t by, pi divided by 12, okay? And I take 2 pi and divide it by that. So 2 pi divided by pi over 12. Okay, let's multiply by that reciprocal. Boom, boom. What I do to the bottom, I also have to do to the top. Boom, boom. 24. That's the length of one cycle. That should make sense because I only go to 24. Okay, I went through that rather quickly because that's a review from Algebra 2, guys. Okay, all right, so let's start this. I'm going to start down here at 70. I'm going to end at 70. Where is it going to end? At 24. So 70, 24. Okay. My high point is going to be exactly in between those at 90. So between 0 and 24 at 12, I'm going to go up to 90. And in between those is when I'm going to have my middle points at 80. Okay, so now I just kind of, and remember, it's got to be curvy. Don't connect to, do not do this. Da, da. That is wrong. Trigonometry has a curve to it. All right, that's the graph of capital F of t. Right there. Okay. That was a gimme. That was a gimme. If you want to check on your graphing calculator because you have it, go right ahead. Make sure you are in radians and not degrees. Okay? In fact, let's just do that together real quick. Okay, let's say you forgot, I don't want the key press history. Let's say you forgot all that stuff, amplitude, midline, how to figure out my period or length of one cycle. Okay? Gonna turn this on. Let's go to mode. We are in Radian mode. You can see that flashing right on the word radian. So we're gonna go to y equals. I'm gonna put 80 minus 10 cosine alpha y equals enter. And it is pi, okay, times my variable x over 12. Now again, my window, okay, I only want from 0 to 24 for my variable. We can go by ones, that's fine. Oh no, on the bottom here it goes by sixes. Okay, if I looked here, it goes 0, 6, 12, 18. Okay, my horizontal axis or my x-axis changes, okay, by 6. And my y-axis goes from 60 to 100 by 10. So let's do everything just like our paper does, okay? 60 to 100 by 10s. And if I graph this bad boy, that's exactly what we should get. It starts low at 70, hits 80, peaks at 90, hits 80 again, then comes down and ends right at 70. Okay, here's 70, where it starts and ends. Here's 80, our middle, and then here's 90, our high point. That is fantastic. We're good. We've checked it on the calculator, which is good. It's good even if you think you got it. I mean, this is an AP exam. Check it on the calculator. All right, check it on the calculator. All right, so find the average temperature to the nearest degree Fahrenheit, okay, between time 6 and time 14. Anytime they have us find an average, okay, anytime they have us find that average, you are going to have to integrate, okay? If it's an average rate of change, and let me stop and say this right now. If it's an average rate of change, you need to do change in y over change in x. It's the basic slope formula. That's like Algebra 1 slope formula. But when they want to find the average value, okay, the average temperature, okay, I am going to, let me do this up here. Actually, I'll do it down here. I've got to integrate with using my average method, I guess I'll call it. Let's do this in green. So B, I'm going to integrate from the two bounds, from 6 to 14, my capital F of t, dt. But then since it's the average, I'm going to multiply by 1 over 14 minus 6. All right? You need to write dt or you get points taken off. And oh, by the way, we get a calculator. What I've written right here tells them how I'm going to get my number. All right? Tells them how I'm going to get that number. So let's do this. Let's put this right in the calculator. Second quit. That was a beautiful graph. Alpha x. No. Alpha x. No, it don't work. On the handheld calculators, if my students hit alpha x, it brings up that fraction, but it doesn't on the board here. So I'm going to have 1 over 14 minus 6 times math 9, which is the integration from 6 to 14 of that fancy little fraction, or excuse me, equation we have, 80 minus 10 cosine alpha y equals enter of pi times x over 12. And make sure we got to close out this parenthesis. The current ending parenthesis, this one right here, currently matches this one. Okay, so I need one to match this one right here. So let's close that down. Bam. Ex, and hit enter. 87.162. So I will call that 87.162. Find the average to the nearest degree. So that's going to be 87 degrees. Okay, 87 degrees. That's the average. All right? Good, good, good. Good. That's it. Done. So far, A and B were pretty easy. Yeah. C. C. An air conditioner cooled the house whenever the outside temperature was at or above 78 degrees Fahrenheit. For what values of T was the air conditioner cooling the house? So I need to figure out for what values down here, okay, basically when it got above 78 degrees because the AC turned on when it was above 78. So all I'm going to do, right? All I'm going to do is I'm going to take f of t and set it equal to 78 degrees and see where they cross. So right about here is 78 degrees. I got to figure out what values these are. Okay, that's it. So anytime I have two equations, cosine pi t over 12 equals 78, I just put both the graphs in the calculator and use the intersect function. Remember, we get to use a calculator here. That would be, I mean, not impossible to solve, but it'd be pretty, pretty complicated. I mean, compared to using the calculator, it would be. I already have in blue my capital F of t. Let's get rid of these arrows. I want to see when that's equal to 78. Let's graph it. Okay, I need these 2 points of intersection right here and right here. Look at that. It was right before 6 and right after 18. Our graph on our paper is pretty spot on. So let's figure out what those are. Okay. I want to go second, trace, because I want the calc menu, and I want to find the intersection point. Now, keep in mind, I want to get closer. I've got to do this twice, this whole process. Hit enter once, hit enter a second time, then hit enter a third time. So we have 5.231. This number will round up to a 1. Or, yeah, I'll be okay. The 0 will round up to a 1. So 5.231, that's our first one. So that happens at t is approximately 5.231, comma. Now we got to do it a second time. Okay, right after the 18. So don't just start hitting enter 3 times. You've got to begin the whole process again. Second, trace, intersect, which is choice 5. And now, oh my God, I've got to slide all the way over. So I am just going to hold with the mouse this button, because when I try and hold it on the board, it opens some weird little menu, toggle button, I don't know. There we go. Enter once, enter twice, enter a third time. 18.769. This will stay at 9 because the number after it is less than 5. So we got 18.769, all right? Those are the 2 values, okay, from when the calculator, the calculator, I'll be okay. You can tell I'm a math teacher. When the air conditioner is cooling the house. Okay, so for what values of t? Now here, this is important. It doesn't just turn on at this moment and turn off, and turn on at this moment and turn off. Okay, let's look at our graph. It's going to start turning on here, and it's going to be on this whole time. So all the t values in between here. I don't want just the end points. I want everything in between. So when I write this answer, I better write it as an inequality because I want all the values in between. That air conditioner is going to be on at all those values in between, not just when it starts and ends, but everything in between. So I better write that as an inequality. Okay, and those are in hours. There you go. All right, so far we graphed, which was A. We did the second one, which was easy, B. We did this third one, C, which were really, graphed a second thing and did the intersect function. This has really been easy, and the calculator's been a huge, 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 huge help here. So let's read what this last one asks before I start changing the color of my calligraphy pen. The cost of cooling the house accumulates at a rate of 5 cents per hour for each degree the outside temperature exceeds 78. Okay. What is the total cost to the nearest cent to cool the house for this 24-hour period? All right. So what I want to do what I want to do is I want to figure out, okay, my temperature, all right, between, okay, let me state it this way. Let me state it this way. Let me pick my pen first before I start talking. Orange, good. D, right here. Okay, first of all, we're just talking about the AC. The AC is going to start turning on here. It will be on the whole time, and it will turn off here. Okay, if it's 5 cents per hour for each degree, it's above 78. Excuse me, man, wow, I need some coffee. These are the times that it's above 78. Okay, those are the times and everything in between. So I need to add up all of that and multiply that by 5 cents. Okay, so I gotta add that to 5 cents. So I'm going to integrate, okay, my capital F of t but I'm going to subtract 78 from that. Okay, because I want it when it's over 78. So let's say it's 80 degrees. Okay, look here at the bottom. Okay, that's really only, I'm not going to take that and multiply it by my nickel. That's really only 2 degrees above 78, right? So I multiply that times 2. Okay, not the 80. So that's why it's critical. This will give me the overall, that would give me like my 80. But I want to subtract 78 from that because I'm only paying for the 2 degrees above 78. I'm not paying from degrees 0, 1, 2, 3. I'm not paying 78 or below. Just the degrees above 78. That's why that's critical. All right? And I want that from 5.231 to 18.769. How come? Because if any time before this or after this, I'm not above 78. We just made that determination in part C. That's when the air conditioner is kicking on. All right? Don't forget I need my DT. Oh, and when everything's all said and done, whatever this equals, I'm going to multiply it times a nickel, 0.5. All right? So let's go ahead and do this. Oh, man, look at all these fancy arrows and such. Turn this back on. Okay, let's quit here. And, oh, let's hit enter. I'm going to kind of cheat here. And by cheat, I don't mean cheat. This isn't cheating. I just, I'm going to try and take shortcuts when I can. We're going to get rid of this fraction. Delete, 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 delete. And down here, it's 5.231, I believe I've written down here. Yeah, I do that. 5.231. And up here, it's 18.769. Now, I'm going to put another parenthesis in front of this 80 and one after. I'm going to put a third closing parenthesis back here because I want to take this whole f of t function and then subtract 78 from every value, okay? And I'm going to hit enter. These are the total degrees between these hours, if I add them up, that are over 78. Don't forget, I got to multiply that times 0.05. Okay? Multiply that times 0.05. So, 101, what I have written here in orange already is enough. I mean, it tells me where I'm going to get my answer from. So let's go here, orange. I mean, if you wanted to, you could do 101.927 times 0.05. Okay, but you really don't have to write this because this is where this comes from. Okay, but I mean, if you want to be efficient, and it's 5.096, and if it's money, $5.10. That's what it's going to cost for that specific day. Okay, remember it's over 78 degrees, not over like some of you guys that turn that AC on once it gets over 68. No, 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 no. In my house, okay, when it gets over like 70, 72, then I'll turn the air on. Okay, and I heat. Okay, wait. Yeah, no, wait. This is AC, not heat. Oh my God, what am I doing? I don't know. I just leave it at 72 the whole time. Just leave it at 72, kids. Don't touch it. Your father will get so upset. But I cool down to 72 when I heat up to 68. I make that adjustment because it's better for the environment. It's better for the house. And they're like, oh, you guys will, I'm not going to get into dad things. I'm turning into my dad right now in front of you guys. All right, we're done. Let's get rid of this thing right here. We don't need it anymore. Let's cut that out. Bam. Okay, that's question 5. Another very doable problem if you understand setting these things up. Okay, anytime you get to use a calculator, if you can just set the problem up, you're good as gold. This really hasn't been that difficult of an exam to this point. I can understand D, subtracting the 78 might trip you up there on our 4th option, D, what I've written in orange here. All right, but other than that, everything was pretty easy. Okay, hey, like the video. Again, that really helps me. That makes me keep doing what I keep doing. All right, follow me because question 6 coming up. And also, I think I'm going to put on there how to solve a Rubik's Cube, because I do that, and I have 2 Rubik's Cubes on my desk, and kids, my students, especially my calc students, pre-calc students, they're mesmerized by it. And when I show them that I know how to do it, immediately they need to know. So I might put up one of those things. I'll relate that to algorithms, right? Instructions on how to solve a problem. Yeah, that has math relevance to it whatsoever. All right, like the video, follow me. I will see you for the final question of this 1998 exam. And then we're done with it. Then maybe we'll do another one. Have a good day. See ya. Bye-bye.